Hello, Assalamu alaikum. This is Anas. Today our session will be based on IoT, Internet of Things, for their deployment in smart cities, smart homes, and we'll talk about the configuration of the IoT using networking infrastructure like Wi-Fi, router, and other IT or computer devices. Before to start make configuration using Cisco Packet Tracer, I would like to share you today's session agenda will be based on IoT introduction, the infrastructure of IoT using wireless, talk about IoT layers, IoT protocols, smart homes, smart cities, and we use Cisco Packet Tracer. We can create a scenario, design a scenario for IoT. Then we do a configuration. After that, we have more session for conclusions. So let's talk about IoT. Before starting talking about IoT, I need to focus that the last decade, there's a booming in technologies in internet, IR4, IoT, artificial intelligence, machine learning, and many technologies are booming. So in the meantime, there's a threats also are booming and becoming more complex and sophisticated for the networking and IoT devices. We have some small talk about it in the next slides. So IoT, what IoT? IoT is a smart device, communicate with smart device, okay? For example, maybe you have your home, you have lamps, fans, and some appliances. You can convert these appliances to smart appliances will be IoT device. Because smartware, you can communicate with these devices, control it remotely, okay, and do a management of these devices for better power consumptions, for efficiency, and more things. You can integrate all of these devices. Okay, maybe you have different devices, smart IoT devices for different facets of life or different domains, like in industry, in industry and medical domains, in agriculture, smart homes, smart cities, any kind of different domains. It can be applied IoT. So before to start talking about IoT layers and IoT protocol, I would focus on infrastructure for IoT. IoT using internet or any media to communicate with each other, where you can share information for better experience and can be managed remotely in central location or central control room or control systems, all the IoT devices for better experience and management in any kind of any domain. We'll talk about it later on. So there's wireless standards. I just mentioned the new standards wireless. Okay, we have Wi-Fi 5, Wi-Fi 6, Wi-Fi 6 extended, and Wi-Fi 7. All of them, they are 5G technologies. Don't mix with 6G or 5G. 6G, it is second new technologies in Wi-Fi. It has better or higher speed rate, can reach to terabytes. Still now not available for, not ratified. Still there's research and development in these things. But I can just mention about those new technologies in wireless for 5G. The first one, which is 802. Let me open my, okay, good. We'll talk about 802.11ac, which is work on 5 gigahertz bandwidth, bands, okay, and the maximum rate 3.5 gigahertz. This is theoretical speed of wireless, but the actual throughput or speed could be reached up to 1.8 or maximum 2 gigabit per second. Okay, using channel from 2040 80 and 160 channel width, and using modulation 25.6 cam. It using MIMO, which is multi-user, multi-in, multi-out. Okay, uses 4 spatial radio spatial, and I mean this for radio spatial streams, as I mentioned. Also, not support multi-link operation. We'll talk about the support, which is in Wi-Fi 7. Okay, so Wi-Fi 6, which is 802.11ax, the standard name, and using 2.4 gigahertz and 5 gigahertz. The maximum rate speed will reach up to 10 gigabit per second. It is theoretical, but the actual throughput could be reached up to 4 and maybe maximum 5 gigabit per second. So they're using maximum channel bandwidth 160. Okay, using QAM 1024 modulation, and it has multi-in, multi-out MIMO with multi-user 8 spatial stream of radio frequency, and also not supporting multi-link operation. And now Wi-Fi 6 extended, it is 802.11ax using both bands 2.4 gigahertz and 5 gigahertz and 6 gigahertz, 3 actually, not 2. Okay, 3 frequency bands for wireless. It reached to 10 gigahertz, around 10 gigahertz. So also similar to the previous one, is maximum using 160 megahertz the channel width, and uses the same modulation CAM 1024, and has also MIMO 8x8. Okay, and to understand what MIMO look like, you have one access point, 8 access points. Okay, look like 8 access point with each access point it has antenna. You can consider like this. Okay, and supporting 8 spatial streams frequency. This is the last one, Wi-Fi 7. The standard 802.11be. It uses also 3 frequency bands, 2.4, 5, and 6 gigahertz. It can reach up to 46 gigabit per second. Theoretical. Okay, imagine you have 4 Wi-Fi 6E in Wi-Fi 7, because 4 times speed, and the bandwidth, the width channel will reach to 320 megahertz, and the modulation CAM 4069. By the way, which can make the higher speed the channel width plus modulation. It can help. There are very crucial vectors can help to have higher speed, which is 46. Using 16 spatial stream and 16 by 16 and supporting multi-link operation, which is MLO. What that mean, multi-link operation? That mean these technologies, it can work with all 3 bands together, 2.4, 5, and 6 gigahertz, all together can work in the same time. Okay, only these standards, the latest one of 5G. This is in the infrastructure of wireless. Very briefly about the speed, the standards, the modulation, the rate of speed, the frequency bands, and the spatial streams number. Just I covered this for infrastructure. By the way, most of the countries deployed 5G wireless in their cities to give faster internet and lower latency. Could be reached to less than 1 millisecond for latency, which is good for most of the applications and real-time applications as well. So let's move to the next slide. Next slide, we talk about IoT layers. Okay, as you see here, we have around 5 layers for IoT. Those layers I can let's talk about one by one. The first one, it will be perception layer. Perception layer is is data gathering. That means the sensors of smart devices, actuators, okay, or physical objects are available in this layer. As you see from the photo, all of these smart devices can support it and available in this layer. Okay, it consists of sensors, actuators, devices. It can collect the data from the environment. Okay, and can gather real-time information. So the next layer, which will be network layer, layer 2. This is one. Okay, network layer where the data transmission. That means this layer is responsible for transmitting data from perception layer to processing layer, which is the upper layer, which is layer 3, called processing layer, or middleware layer. Okay, and this processing layer, before that we talk about network layer. As we mentioned in previous slide about Wi-Fi. Wi-Fi is most important network layer for IoT infrastructure, I mean, and it helps for or responsible for transmitting data from perception layer to processing layer. It includes different communication protocols, as I mentioned, Wi-Fi, maybe Bluetooth or Zigbee, or sometimes cellular networks. So let's talk about the processing layer. As we mentioned here, decision unit and data analytics. This layer provides the user interface, the application that utilize the process data to deliver meaningful information. Okay, also include application software, dashboards, and tools to help the user to interact with IoT system. This is number 3, processing layer or middleware layer. So about application layer, and let's talk about application layer and business layer as one layer. Actually there are 2, okay, but usually we gather both of them as the upper layer of IoT, where we have graphical data representation and we have business models, where we can, for example, the business layer can focus in managing and optimizing the business process, where we can observe of the IoT, do management and controlling, and get the most valuable information, also visual information and reports about this IoT different management of different domains of IoT. Because each IoT, it has different domains, like smart city. Smart city, they have subdomains like traffic and automation, car automation, car traffic, jam. This is one subdomain. Maybe they have CCTV, surveillance camera with pollution. This is different subdomain, and so far. So we'll talk about this kind of application in the next slides. So let's move to the next slide. Next slide we'll talk about protocol. Okay, let's talk about the most important protocol nowadays for IoT. It's called MQTT. Let's write down this protocol, MQTT, which is messaging, queuing, telemetry, transport, messaging protocol. This protocol is very important and widely used for IoT application because of this protocol. It works for lower bandwidths, where in some area maybe the internet have lower coverage of internet or lower speed of internet. It can work in very lower speed. That means it works in lower bandwidth, and it can work with limitation or constricted devices which has lower memory. because IoT is very light devices, has lower memory. This is good for lower memory, plus has less error packets or less packet lost in the communication. So it is very proper protocol for IoT. It's used in many IoT domains like hospitals, medical, industry, agriculture, smart city, smart home, and so far. So as we see here from the slide, this protocol based on publish, subscribe, or publish subscribe nature. That means we have a publisher and subscriber. For example, we have publisher number 1, okay, which is smoke detection or maybe fire detection. This publisher, it publishes a signal to the other component, which is, excuse me, let me remove this. Okay, first we have a publisher, the first component, and we have subscriber called IoT clients. Okay, IoT clients or nodes. These nodes could be subscriber, could be publisher. Publisher means it publish the information, look like a smoke detector or fire detector or maybe motion detector, where it detects a motion or detect a fire or detect a smoke and publish this information to the second part of IoT, which is a broker, the main control unit of IoT. Okay, this broker, it can receive the information from subscriber and then push it to subscriber, from a publisher and push it to subscriber. Subscriber will receive the information from the publisher through the broker, which is the main control unit for IoT. Okay, for example, when the fire detector detects a fire, it can publish the information using what? Using topics and messages. Okay, the other two part of IoT. We have 4 parts: IoT clients, publisher and subscriber. We have a broker. We have topics and messages. Topics mean, let's say, the publisher fire detection using what? Using sprinkler. Using fire detector topic. Okay, and send message. Let's say the value of the information to the broker. Broker will send this topic, okay, to sprinkler. For example, if you have sprinkler here, subscriber, and using message other value to let sprinkler works, give a value to work. Okay, then sprinkler will work and distinguish the fire. This is in very briefly. And by the way, the IoT protocol MQTT is susceptible to many attacks because of the nature of publish and subscribe, where the broker can accept any kind of subscribe. It is one thing. Maybe also this using a TCP protocol, that means oriented protocol, where this acknowledgement of receiving the packet. For example, when the publisher using quality of service, okay, let's say hackers masquerade himself as a publisher, okay, and send their information to broker. This information look like, for example, maybe the man in the middle attack or the attackers send this information as normal publisher, but the nature of communication TCP, it required the acknowledgement and will keep without acknowledgement and keep the session open all the time. This is kind of DOS attack. Okay, there's many attack look like DOS to DOS, intrusion, infiltration, man-in-the-middle attacks, and so forth. So this is briefly about a protocol of MQTT for IoT. Next, we need to move to the next slide, which is introduction about smart homes. What smart home? As we see here from the slides, allow user to remotely manage and monitor different home devices, lights, fan, doors, gate, windows, security system, alarm system. As we'll see in the next session, next part of the session, I will configure the things physically to see how it's configured and how it works for better understanding. Okay. For example, this is time for the home. Let's see the next slide. Okay. In the next slide, I will make smart lighting. I will leave the light. I will control the light remotely. Once, for example, there's let's say in the daytime, I would like to make the lights off, and the midnight will be work. Or maybe if there's any motion detection in my home garden, okay. I will light up the light. If there's no motion, I will keep the light off, turn off. Okay. It's good for energy consumption as well. Also, we have different applications like door locks, smart heating, gardening, video doorbells, personal assistant, as we'll see in our configuration. So let's talk about smart cities in very briefly. As you see from here, okay, there's let's say we have many applications in smart cities. Those applications is very good to make management and time consumption efficiency, okay, and automation for better experience and timing. For example, in smart cities, we leverage advanced technologies to improve different aspect of the urban. Okay, for example, smart transportation where there's traffic management, real-time traffic monitor, and will monitor the traffic signals to reduce the traffic jam, for example. Because these sensors, it can CCTV sensor and other devices for traffic management, it can observe there's a peak time for the traffic in some area, okay, and will reroute some cars to different streets, okay, to bypass or avoid this jam. This we can give efficiency to the street and the traffic jam, or even it's called traffic management or smart transportation. So also this public transit will enhance the public transportation system with real-time update to reroute to a different street. It's called optimization for the roads. Okay, and so there's smart parking. Where remember when we go to some parking in the malls, you found there's some parking lights green. That means there's in very far place there's an empty. Go to this one because this will avoid people why are drivers to congest in some area because they know this area it has empty parking where they can use it, or maybe this have no any occupied or empty parking. Most of the parking are occupied by other cars, so you need to go to next lane or next floor, for example. So it's very smart. Give some smart for this car parking. Also good for smart metering for the power, where it will monitor the energy consumptions in some area and the big time, and maybe it can lead or guide the government or the management to load extra power to this area, especially in industry area in the peak working time. Maybe at evening there's no peak time, peak power usage, maybe less power usage. So they give a visibility and the good time and what the load are consumed, how to manage this power as well. So there's kind of environment monitoring, like will monitor this any pollution in the environment or the air. Other application for smart city will look like water management, water monitoring, usage, detect any leaks in the water, very good technologies and management. Also, there's for many, let me remember what I can, public safety, okay, the surveillance of the CCTV will be observing the area, and it can observe any suspicious movement in this area because there's some function in this CCTV to observe a zone area and tell if there's any suspicious movement or any suspicious action. It can observe and give alarms and notifications to the management or to police or whatever. Also, it can observe the plate number of the cars, okay? It also can make crime prevention, where it can send this information to the police to observe or focus in this area and take fast actions. So also used in hospital, like wearable devices, in health metrics, where it can real time give a feedback about some heart attack patients if they need fast emergency or taking care. Also, there's some hospitals, they give wearable tags to some patient, like maybe in nursery, the newborn babies, to not mix between these babies, okay, or maybe anti-hijacking actions. Or in some area, in some movies, you can see some nurses working with some criminal to hijack a baby. For example, if this baby hijacked and he go in different route in the hospital, the TV cameras and other sensor give indication for the management of the hospital where the location of this nurse taking maybe the baby in different zone, not allowed to take this baby to different zone. Only should follow the permission zone to go from nursery to maybe doctor and vice versa, for example. Okay, and maybe if there's any violation, it give smart sensors, alarms, and give alarm to the access controls, or the hospital will lock the doors, not open the doors. Vice versa for the firing. If there's any firing, the firing detection will give alarm, and all the access control will be opened until people can go out easily for hospital. This is some kind of applications about smart cities or building or hospital applications. I just give you very briefly. So let's go to the next slide. Sorry. I think let's talk about application for home applications. I think I want to go for this one. Let's go. I did this one at home myself. Okay, I have Arduino chip. Okay, as you see here, the name of the chip. Okay, this is called Node MCU, which is there's one okay, ASP A266. Okay, it has a lot of pins, and I connect 4 electrical relay. Okay, sorry, 4 electrical relay. This one, let me open. Okay, this is a MCU. It has many pins, and I connect electrical 4-channel relay, and I connect different lamps and fan, maybe different appliances, normal objects and appliances in my home, not smart one. I convert those devices to smart devices, and after that I connect my MCU to internet using my Wi-Fi to our home routers and connect to internet. I have in the cloud IoT cloud configuration using Arduino cloud. Then I'm using Alexa as application, or maybe Google Assistant application, to access to the cloud and control of all of these smart IoT devices, okay, where I can run the fan, turn off the light, open the garage, observe or the home, or I can manage everything. It's called smart home, okay. Just as briefly now, I need to focus in most important Cisco packet tracer, how to configure the IoT. So I will stop here as part 1, okay. Then I need to configure this kind of IoT to show you how we can configure the smart homes, okay. For example, this is light or lamp or alarm with alarm, and we have motion detection. For example, I will use a simple configuration as home, okay. After that, I will do a configuration for large home, okay, enterprise home smart, where I have many applications of IoT, okay. Especially we have speakers, we have or solar panel, okay. I have motion smoke detection, motion detection, okay. Many applications. This one I will do it next video, okay. Maybe today I will do it, okay. Thank you very much attending my today presentation, and I hope you can watch my next part, how to configure all of this information with networking appliances like home gateway, routers, maybe lightning, fans, all of these appliances. I will configure it for you and check how it works. So thank you very much for today attending, and see you next part of configuration the IoT devices using Cisco Packet Tracer. And don't forget to subscribe and press like, and encourage me to do more videos. Thank you.